Welcome back to Switch to Linux. Well, today we want to do a Raspberry Pi project, and what we're going to do is extend our wireless network. This is particularly useful because I'm using pfSense, which is based on BSD, which does not handle drivers for wireless cards nearly as well as Linux does. So while I do have a wireless network connected to my pfSense box, according to some testing here, I'm actually only able to get 20 down and 11 up on my card, which is a BGN. I'm not sure if there's A in that card or not. But it really can't support A anyway, unless something has changed since I've been researching into this. Now, I do have what I use for my own personal network is I use my old router and I put it into a bridged mode so it behaves as a wireless access point, and it actually gives me 4 more ports. It's a little bit slower because that's only a 10100 router. That's a Linksys E1000. That one actually gets me pretty good speeds, which is 37 down and 12 up. And that is actually based on a card, a computer here, which has a very high quality AC wireless card in it. But what you want to do if you want to maybe not spend about over $100 on a wireless access point, if you need to extend out your network, you can actually use a Raspberry Pi. I'm using a Raspberry Pi 4 with 4 gigs of RAM. I'm using a 4 gig of RAM Pi. I actually use these nice Sunfounder acrylic cases. I'll do a video about how to put the Pi into these cases. They're very nice. All the ports are accessible, and these particular Pis that I have here, I do not have intentions of taking them out of the case anytime soon. So this is a good case to put them in very nicely. And this case actually comes with a fan and 3 heat sinks. So you actually have a lot of good equipment with that $5 case, which is quite an incredible price for that. So I have it hooked into the Ethernet card, which is that is a the Ethernet port on this is a 100/1000, so it's a gigabit Ethernet port. And the only other ports I have in there set up, I don't actually have anything else set up to that. I'm just running power to it and the Ethernet. Now, when you are going to be setting up your Pi for doing this, you are probably going to want to hook up your Pi to a monitor and put a keyboard on it. The reason is the steps that we're doing, it can mess up the network for a short period of time as it's resetting things. If you're doing this entirely over SSH, then you might actually find yourself kicked off of the network, and that would kind of be problematic. All right, so all of the instructions we're going to do are going to be on Raspberry Pi's forums, but there's actually a step that they're missing if you'd like to turn on the AC network on your system. So the instructions they have get you a good functioning G network. We want to go up and talk about how to do the A network and how to fix that problem in their documentation. So let's head on over to the forums here, and actually this is to the Raspberry Pi documentation. There's actually 2 ways of doing this. One of these is setting up your Raspberry Pi as a bridged wireless access point, and the other one's going to be as a routed access point. Your difference is your routed is going to create a separate IP address, so this is excellent for a guest network. So if you want to set up a guest network, this is the method you want to do. This is not the one I want to do today, so we're going to use the bridged network. The difference is, looking at the documentation, you can see my basic router on my internet has 10.10.0.1, and you can see that the PCs on my basic router are going to be all based on the 10.10.0 subnet there. All right, their Raspberry Pi, which is in the top box, is going to have a different IP address assigned, and anything attaching to that is going to be able to access the network, but it's not going to be accessing the ports on the network, and the client is going to have a different IP address. That's fine, but for me, the only reason I use wireless access is so the few smart devices like smartphones and tablets that I have can actually access my network stores. So I need to use the bridged wireless access point where anything connecting to it is on the same subnet, and so it can access all of my individual ports. All right. So what we're going to do is walk through this, and I'm just going to go through and explain the instructions here so you understand what we are looking at. So you need your Raspberry Pi set up with, they changed the name of it. It used to be called Raspbian. I think it's just Raspberry Pi OS Buster now, I guess is what it's called now. So with this, you got to get this guy set up, and that's exactly what I have running. And actually, this Pi also contains a network server or a web server for my network. So I took one Raspberry Pi. It has a wireless access point and a web server built into it, and then I'll have another Pi with another function as well. So you do need to make sure that that is set up. We're not going to walk through how to set up your Raspberry Pi. You might want to, like I have SSH hooked up, but again, you are going to want to set this up with a keyboard and hooked directly into a monitor, just because you're going to run into a case, or you could run into a case where it resets the network. In my case, it did not do that, simply because I had already had this guy set up as a web server and it was locked into the IP addresses and things like that. But that's what you're going to want to do. So the application that allows you to do this is Hostapd. So this is the Debian application that allows you to add the wireless access point features onto a wireless card. Here is the Hostapd information here for the package. You can see it's for access points. And they're just going to walk through some of the information that you have. Here's the various versions and the various architectures. Now, when you set this up, it is actually masked by default. So some people are asking, why is it masked on default? So over here, why is it masked on default? Well, the reason is if it's not masked when you install it, it's going to crash your network. And so you want to make sure that it is unmasked until you're ready to actually use it. This is why it will mess up your network if you do not have everything set up right. All right, so anyway, we're going to install it. So apt install Hostapd. You're going to unmask it and then enable it. So the unmask it allows it to be seen and accessed on the network. And the enable is going to make sure that on startup, this guy is going to boot. So that way, when you start up your Raspberry Pi, it is all set up there. All right. So the next thing we are going to do is we are going to create the bridge. Now, if you've done a pfSense router, you'll know the importance of the bridge, taking all of the connections, putting them under a bridge adapter. So it just kind of walks you through the creation of the individual files. So you're just creating a new file in etc systemd network bridge-br0.net drive, and then you're just defining the drive. So this is the name of it. So you're going to be able to call br0, and it is a bridge. So the bridge is going to connect the Ethernet port with the wireless access port so that they're behaving connected rather than behaving separately. All right, so in order to build the bridge with the network wireless, you're going to need to add the built-in network interface as a bridge member. So now we are creating members inside of the bridge. So the ETH0 is Ethernet 0. You're going to add that into the bridge. Again, following all of these instructions until we get down to the bottom is going to work. But the bottom, they don't have it corrected yet, and I'll show you what we actually need to do. So the WLAN 0, this is the wireless port. So we're going to enable the network D service. So this one here, now we're enabling it just like we had enabled Hostapd, wow. Now we are going to be enabling the systemd network D. All right, so that's nice and easy. This is the part where you're going to want to set up your configuration files. So you're going to go into your configuration files for your individual ports there, and then we're going to find the interface lines if there's any of these, and then we're going to deny these interfaces. This is going to block wireless or Ethernet from behaving as they're supposed to, and instead we're going to interface BR0. So what I'm going to do here is I'm going to jump on over. I'm going to show you this is the first step that gets a little bit more complicated. So let's go ahead and head on over to a server here. Let's go one more up. And if I were to paste this guy in, sudo nano etc dhcp cd. So this is what we have. Now, again, some of these had already been changed because I have a web server running over here. So most of this is just going to stay the same. And then what we needed to do is, you can see I'm already defining a static IP address. This is for my individual server. And then down here, we are denying these two. So these two will not function separately anymore. Now we are creating the interface BR0. So this guy here means that the two ports are going to be connected together. So that's what we need to do over there. All right, so now to ensure wireless operation, we do need to have a country code. It will not broadcast in the 5 gigahertz spectrum until you have a country code set up there. So your list of country codes here, you can just look up Wi-Fi country codes, and then you can just kind of find your country. These are the codes down here, the 2-letter codes. Notice that they are all capital letters. So you don't want to do lowercase, you want to do capital letters in these. Find whatever country you are in. In my case, we are down here in the United States, so we're doing the US. If I were in one of the outlying areas, I would use UM, but we're not. We're doing US. So you're going to want to have that. And then you need to make sure that the wireless broadcasting is not disabled. So the RF kill unblock command, this guy here is going to make sure that the wireless code is going to function right. All right, so now we want to create the configuration for your Hostapd. So this guy here is the part where we have a couple of changes that we need to make. Okay, so if you actually go and look up what should be in the Hostapd configuration file, you'll actually get the giant list of everything that's there, and it's quite extensive. And so here's what it looks like. So of course, if you've not looked at a terminal-based configuration file before, all of the number hashes here, these are all the hashes that are comment lines. So this is just really explaining what everything does. So you can see this is the interface with the WLAN 0. But if you want to use instead a bridge 0, you can do that. You can set up your drivers. To use one of these, you just want to just delete the hashtag in front of it there. And then there's a variety of different drivers and things like this. So there's a whole lot of detail in this file. You could go through it. But what they give us is actually pretty much what you need. So you're setting the country code. In my case, it's US, not GB. And what you're doing here is you're basically enabling the 5 gigahertz transmission. If all you're doing is the 2.4 gigahertz BGN, you don't need to actually have the country code. But if you do want the little bit better performance with the A, then you want to do that. Interface WLAN with the bridge. So we're enabling both of these guys. The interface is telling us to broadcast through the wireless, but we're running it through the bridge. This guy here is the name of your individual network. The mode, this is the one that some people have had an issue with, where the modes for these, as they say down here, the G is what they have here. You can go up to A, so you can either go A, B, or G. You can see that a Raspberry Pi 3B and onwards can support the 5 gigahertz with A. But if you set this to A, it's not going to work. I'll explain why that is in a second. Here's your channel, MAC address, ignore broadcast. If you want to set this to 1, then the broadcast will be hidden. The SSID will be hidden. I generally hide mine by default. I didn't in this case here for testing purposes, but I generally don't. I generally hide mine. It's not going to prevent the hacker from figuring out what my network is, but it is going to prevent my moron neighbor from trying to get in there. And so that's that. And I can't say moron neighbor. One of my neighbors is actually a computer guy too. So, you know, prevents us from fighting each other, I guess. I don't know. Anyway, WPA, this is, of course, the type of encryption, 1 or 2. And forget if I have 1 or 2 set in mind right now. And then the passphrase, there's no quotes or anything, but this is going to be your passphrase. I set mine for the purposes of the demonstration here to 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it's the kind of thing a moron would have on his luggage, but that's not really what I use. I just put that in there so because I'm going to show you the file for default. And then what is the type of management? WPA, PSK, TKIP, and CCMP. So that is how you're going to set this guy up. Now let's go ahead and have a look at what I actually did on mine here. All right. So this is what I'm running, country code US. WLAN is 0 for the interface, and then we're running it through the bridge. I used this SSID, which kind of matches some of the other SSIDs I have. It's just this was for the Pi. You'll notice that I am functioning on A, but look at my channel numbers 165. This is actually the part that is not discussed anywhere in their documentation, and that is the missing step if you want to be transmitting on the 5 gigahertz frequency. I'm going to show you how to fix that. See here I'm doing, I am broadcasting in this case. This guy is WPA2. Here's my amazing, totally complicated password. Don't use a password like that. I just have it right now turned on for sampling. So hopefully nobody's trying to access my network right now. But anyway, I'll go ahead and fix that when the video's over. I did test this out. I added for testing because the A was just not working. And you'll find a lot of people asking questions about how to get A working. And nobody had that information until I kind of dug in deep, but I was trying adding drivers and things, and it turns out that I did not need to do that. All I need to do is change this channel 165. How did I know to do that? Well, the channel is actually going to come up on the IW list. So if you go in IW list, you're going to see this mess here. And what this is actually going to tell us is our bands and what we have going on. So band 1, this is my 2.4 hertz band. It should say that here somewhere. Maybe it doesn't specifically. But we do have 2 bands here. And you can see that it's transmitting down here on these channels. So these are the channels that tells you which frequency specifically you are going to be using. So you can technically use anywhere between channels 1 and 11. If you go with 12, technically it's the channel it's used, but the Raspberry Pi does not use it. So if you use channel 12, it's actually going to fail on you. And I actually found that the channel was the issue by consulting the logs. So check your logs, people, if things are not working. And that actually solved it. So the band 1 is the 2.4. The band 2 is actually the 5 gigahertz band. And so with this, what you can do is you can see the various stream supports, but then you look down here, the numbers in the brackets again are the channels. So the documentation says just change that G to an A, but it doesn't say anything about the channels. You actually have to match the channel as well. So again, you can't do 34, you can't do 38, you can't do 42, you can't do 46 because those are disabled. 36 is an option, 40 is an option, 44 is an option. There's a number of other things down here. What I actually did is I picked 165, which is the last channel that's there. So mine is transmitted at 5825 megahertz there, is what it's transmitting at. And so that is how all you had to do to get that to work. Now there is another command, I forget exactly which one it was. I had to install the package for it to track down and show that it actually was transmitting. It just wasn't connecting right because I did not have this configuration file working right. Again, if you change your mode to A, you need to change the channel to something that is broadcasting and enabled on your Raspberry Pi, as you can find on the IW space list file. So that is actually what you needed to do from there. All right, so once that is done, now you can run it by rebooting your system. And then once you are rebooting your system, then you can go ahead and find that in your network. So, all right, so and here we are. It is on my phone. It's the one that we are connecting to there at the top. And we are completely connected. And somebody actually created a network around here in my area. It says BLM terrorist group. I kid you not. Somebody did it. If it didn't show you all of the other neighborhood networks that could pinpoint where I am, I would show that to you, but it's hilarious. So that is all you need to do. So now every time you turn on your Pi, it will boot yourself up. Now you might be asking the final question. How well does that actually work? Is this actually transmitting, or do I have to be like 5 feet from my Pi? Well, it actually turns out when I did my testing of this that it actually broadcasts fairly well. So I was pitting this against my Cisco Linksys E1000 router, and it actually has a very comparable range. So this Pi right here is in the corner office. The Linksys router is actually downstairs in the back room. And so if I were to walk out the distance out, then the Cisco router will drop off quicker than the Pi if I'm walking out the front door because, of course, the Pi is closer to the front and doesn't have as many brick walls in between. But if I go out to the back, of course, I see the Pi. I see the Pi a little bit less, but I see the Cisco router a little bit more because it's kind of right outside that back door. So, but looking at it and how the span goes, it does actually have a transmission range fairly comparable to the Linksys. My guess is the Linksys is going to be a little bit more powerful, but nevertheless, we are actually seeing very, very comparable ranges. So it's not cheap. It's not something that's you got to be close to it. It does seem to support itself, hold its own, just like any other router does. So there it is, Raspberry Pi wireless access point, how to set it up, and fixing those little issues in there. I did actually go into the forum post and detail my findings in there. And as far as the speed is concerned, whereas the Cisco gets 37.7 down. The Pi is actually getting 24. I'm sorry, the Pi is getting 28.4 down. It's getting 24 down on G. It's getting 28 down on A. So it's a little slower than the Cisco router, but it's certainly a lot better than the pfSense router. So it does work well. It gets you a good wireless access point. You could easily mount it somewhere, and hey, you could actually send power to it over Ethernet if you wanted to as well. So those are other options for you. So there you have it. There's how to set up a Raspberry Pi wireless access point. Leave your thoughts, your questions down below, and I'll do the best to answer those. Thank you for watching this video from Switched to Linux. This channel would not be possible without the backing of the program supporters scrolling on the screen now. You can be a supporter at Patreon at patreon.com/TOMM or at thinklifemedia.com. I also want to thank the open source community who creates such excellent software that makes producing this show possible. Please remember to support your software communities. Thank you, and I hope that you enjoy switching to Linux.